Good morning. Myself Ramprasad Raula. I am presently working as a senior assistant professor in the Department of ACE, Sri Vasavi Engineering College. Today, I am talking about electromagnetic theory, wave and transmission line. This is the subject. In order to better understanding of this Emtl, we proceed with the basics. The basics covered by vector calculus and coordinate system. If you thoroughly understand these basics, electromagnetic theory is very simple to understand. See, course is electromagnetic theory, briefly introduced. So E stands for electric field, M stands for the magnetic field, W means electromagnetic wave. So unit number 1 covers electric field, unit number 2 covers magnetic field, W means electromagnetic wave characteristics, that is unit number 3. Unit number 4 covered by transmission line 1 and transmission line 2. This is the course structure. So in order to better understanding this, we proceed with first vector calculus. So vector calculus, we discuss some of the basic fundamental concepts which are very much helpful for understanding of Emtl once again. So first in the vector calculus, we are talking about first what is vector. So what is vector? So we have a definitions are so many like vector is nothing but it is a quantity which has both magnitude and direction. So first we have to explain what are the examples as come under vector. So there are so many examples are in vector. For example, electric field intensity, capital E, velocity. These are all the examples. There are so many examples. I discussed about these three: electric field intensity and velocity. It having both magnitude and direction. This is the definition. Both magnitude and direction. So give an example. First take an example, velocity. So velocity basically a vector which means that having magnitude and direction. See, for example, we are traveling from Thadapalligudam to Elore by bike. So in that we are traveling by bike with some velocity. For example, 60 kilometers per hour. So this is nothing but an magnitude. The way which are traveling from Thadapalligudam to Elore, that is called as a direction. So therefore, vector coming under velocity coming under vector. In similar way, electric field intensity also. The second point, scalar. Scalar is nothing but which is having only the magnitude, there is no direction. This is only magnitude, no direction. For example, temperature. Temperature, we know that measured in centigrade. For example, 32 degrees centigrade. 32 degrees centigrade. This is the magnitude, but there is no direction for a temperature. So temperature coming under scalar quantity. Like that, we can take in a group of examples. We can describe vector as well as a scalar. So in electromagnetic theory, we have to introduce one point. If it is a vector, describe what is the magnitude and what is the direction. In which direction we have to transfer the signal. In similar way, scalar, it is only the magnitude, there is no direction. We can explain with the help of like these examples. Then followed by position vector. So the title justify position. The position means the point at which we have to identify. Let us take for example the point P I located in a free space. So this point we have to identify. We can locate, we can position. With the help of the point P we can locate with the help of the coordinate system is introduced. The coordinate system is one of the basic component in electromagnetic theory for better understanding. This is X direction, this is Y direction, this is Z direction. See, can you imagine, without coordinate system, we are unable to identify the position. If we introduce a coordinate system, we have X and Y and Z. Both all are perpendicular to each other. X to Y perpendicular, Y to Z perpendicular, Z to X perpendicular. So we have a coordinate system, then we have to introduce an origin point. This is an origin for all the coordinates. Okay, direct drive a line, this is nothing but the position. Without origin, we cannot identify the position. So position vector will be defined. It's a direct distance from the origin. So let us take for example, R is a distance, P is a point. So we can describe RP is nothing but position vector. That is, it is a direct distance from the origin. For example, one more point is there. Let us take, for example, Q. It is also identified from the coordinate system is 0. Let us take, this is called RQ. It is also position vector. If you want to find out the distance between the 2 points, we write RPQ. This RPQ is called distance vector. Distance means between. The distance between the 2 points. We may write RPQ. RPQ, which write as RQ minus RP. RPQ is called distance vector. So this is about the vector analysis. So we proceed with the coordinate systems. So why coordinate systems? First, coordinate systems. The second basic point. The coordinate systems are very essential. Reason behind, for example, our human eye identify only the 2 coordinates, x coordinate and y coordinate. But we are unable to identify three-dimensional coordinate. See, for example, there are 2 fingers. We are observing x direction. We are easily identify 2 fingers from this direction. X perpendicular to y. So from the top view, we can identify at least 2 dots. So object is 2. We are identify from x direction is 2. From y direction is also dots. From this direction, z. But we are unable to see this finger. We can see only the 1. So therefore, we have to prove that one more object is also there because it is 2. So that's why the coordinate systems are very popular. In order to understand any point in the free space, we can imagine one more coordinate. It is proved that there is an object. So these coordinate systems are classified into 3 categories. Namely, number 1, Cartesian coordinate system, or it is also called rectangular. Number 2, circular coordinate system. It is also called cylindrical. Spherical coordinate system, or it is also called polar coordinate system. So these are all the types of coordinate systems. Each and every coordinate system represented by the variables. Here the variables are x, y, z. Here rho, phi, z. Here r, theta, phi. So these are all the variable representations of each and every coordinate system. And one more point we have clearly observed, each and every coordinate system is interrelated because here z is a variable which is repeated on circular. Next, phi is a variable of a circular which is repeated on spherical. So therefore, each and every coordinate system is interrelated. So we have to convert Cartesian to the circular, circular to the spherical, spherical to the Cartesian. So these are all the coordinate systems in order to describe the different types of applications like length, surface and volume. So for example, I will introduce the first one is a Cartesian coordinate system. Number 1, Cartesian coordinate system. It is also called rectangular, which will be represented as x, y, z. So I represented it. Let us, this is x coordinate, y coordinate, z coordinate. If you represented in x, y, z Cartesian, this is origin point. Let us take point P here. I represented point P x, y, z points. So, and one more in vector, one more concept is there, that is called unit vector. Let us take for example a, y. So what is unit vector? Unit vector represented, for example, a, you may write a by magnitude of a, which means that unit vector is a vector whose magnitude is unity, that is called unit vector. It's mentioned along its direction. Here the a direction. In similar way, unit vector is a, it's mentioned along the y direction. Its magnitude is 1. Similar way, this is called ax because it is an x direction. This is called z. This is called az. So ax, ay, az are unit vectors along x, y, z directions. See, I represented point P here. I write vector a along ax plus ay, plus az into az. Here ax, ay, az are components of A. What is component? See, for example, I represented x comma y comma z. I write 3 comma 4 comma 5, which means this is 3 represent x component, y represents 4 is a y component, 5 is z component. So 3, 4, 5. So this is x. So let us take, this is your ax, 3, 4. This is your ay component. This is 4. This is 3. 5 component towards z. This is az. So this is ax, ay, az. The component is nothing but along ax is x direction is 3. You may write 3 into ax plus ay, that is along the direction of y, that is 4 into ay plus z, az, that is 5 into az, where 3, 4, 5 are components of A along x direction, y direction, z direction. Similar way, unit vectors. Unit vector is ax comma ay comma az are unit vectors along x comma y comma z directions. If you want to talking about the magnitude, we may write the magnitude of A is equal to under root ax square plus ay square plus az square. This is the magnitude of A. See, this is the Cartesian coordinate system. Therefore, the variables are x comma y z. Therefore, we represented only x, y, z if it is Cartesian. Now, these variables x comma y comma z having the limits. For example, it is starting from 0 to y. From what extent it is? So, this x comma y comma z variables, the range become every variable having the range, that is minus infinite less than x less than infinite. So which means that this x coordinate starting from plus infinite to minus infinite or minus infinite to plus infinite, this is positive x direction, this is negative x direction. Therefore, this x direction from minus infinite to plus infinite, it will be exist. Similar way, minus infinite less than y less than infinite. So this is positive y-axis, this is negative y-axis, which is extended from what? Minus infinite to plus infinite. In similar way, this is the positive z, this is the negative z, which is extended from minus infinite less than z less than infinite. So we conclude that x comma y comma z, their ranges are from minus infinite to plus infinite, respectively x, y and z. This is about the Cartesian coordinate system. The second one is circular coordinate system. It is also called cylindrical coordinate system. The variables are rho comma phi comma z. So we are talking about a circular, the variables only coming to the picture. So we are talking about the second one, circular coordinate system. Circular coordinate system. The variables are rho comma phi comma z. So we represented first coordinate system first. The basic coordinates x, y, z. We will represent it in circular. So this is an origin point. We may represent rho. Rho is nothing but it is a radial distance starting from the origin 0. This is called an angle is phi. Phi is called azimuthal angle. The range is from 0 to 2 pi, and this is the z coordinate. Already we know this is the z coordinate. So rho, phi, z, these are the variables of circular. We have the ranges. Range is from rho starting from 0. So therefore 0 less than or equal to rho less than or equal to infinite, because it is towards an infinity. Similar way phi, 0 less than or equal to phi less than or equal to infinite. So this phi is called azimuthal angle. The name of this angle is called azimuthal angle. This is 0 to 2 pi. 0 to 2 pi. Next, z. Z is similar to the previous Cartesian coordinate because they are interrelated to each other. So z variable is range from minus infinite to plus infinite. Same thing we have to introduce here, minus infinite less than z less than infinite. So for every coordinate system we represent as a variable, then followed by the ranges. So accordingly, let us take for example, we will represent it in vector analysis. Here this is along rho direction, therefore unit vector is also along the direction. Unit vector mentioned along its the direction, so therefore it is called arrow. Let us take, this is phi. See, look at this, phi is called azimuthal angle. This azimuthal angle make an angle from your x coordinates to radial distance is rho. So therefore this is called phi. This is phi like this, arc type. So therefore this is your a phi. Next, this is z. Therefore this is your z, az. So arrow, a phi, az are called unit vectors along rho comma phi comma z directions. And one more, from vector identity we represented arrow dot arrow is equal to 1, a phi dot a phi is equal to 1, az dot az is equal to 1. So this is arrow into arrow is equal to 1. This is from the vector identity. In similar fashion, for example, arrow dot a phi, it becomes 0. So look at the difference. Rho dot, arrow dot, both are the same. If it is unit other than 1, it is called 0. Similar way, a phi dot az equal to 0, az dot ax become 0. If both vectors are unit vectors, should be multiplied, you may get 1. If other unit vector is coming to the picture, that will be the 0. In similar fashion, arrow cross a phi become az. You maintain the sequence rho phi z. Similar way, a phi cross az equal to arrow, az cross arrow is equal to a phi. See the sequence rho phi z, z phi z rho, z rho phi. If for example a phi replaced by some other, for example az, the resultant becomes 0. So these are the vector identities. If it is a dot product, both vectors are the same, the resultant become 1. Otherwise it will be the 0. Coming to the cross product, we cross the two variables in the sequence manner, that will be the resultant, otherwise it will be the 0. Same thing we have to explain about the same in Cartesian coordinate systems also. We have to describe the same thing. For example, here ax dot ax equal to 1, ay dot ay is equal to 1, az dot az is equal to 1. If not, the resultant become 0. Then accordingly, here this is a point P, we represented unit vector arrow a phi az. Let us take for example, I represented vector, that vector may be a vector once again, that is a vector. I write vector a represented along in circular, that is arrow arrow plus a phi plus az az. So look at arrow a phi az are nothing but the components of a along rho direction, phi direction, z direction, because it is circular coordinate system. In similar fashion, a phi az, a phi, this is arrow a phi az, these are all the unit vectors along rho comma phi comma z directions. If you want to find out the magnitude, under root a rho square plus a phi square plus a z square. This is about the circular coordinate system. In similar fashion, we discuss about the third one, last one, spherical or it is also called polar coordinate system. We represented this r comma theta comma phi. So similar fashion, like that your Cartesian, circular, we are also represented in polar. So first we represented the coordinate system. Once again, the variables we represent. Let us take the standard coordinate x, y, z. In this, first we have to represent an r. This is the radial distance starting from an origin. This is r. So this is an angle theta. Theta is called colatitude angle. Theta is called colatitude angle, range from 0 to pi. Then we know phi. Phi is nothing but this is the phi. Because phi it is already mentioned in previous circular coordinate system. The variables are r comma theta comma phi. Why we mentioned rho? Because phi make an angle from coordinate system x to rho. That's why we mentioned. Actually, r, theta, phi are the variables of polar coordinate system. So let us take this point P we represented. R direction, this is towards R. Therefore, it is an R. Theta in this direction, like this. This is theta, so therefore it is theta, A theta. Next, A phi, arc shape. This is A phi. So where AR, A theta, A phi are called unit vectors along R comma theta comma phi direction. See here the point is Cartesian, circular and spherical. If you're talking about spherical, R, theta, phi only coming to the picture. There is no x, y, z. In similar fashion, if you're talking about circular, rho, phi, z is coming to the picture. There is no x, y, z. The specific coordinate, the specific direction only coming to the picture. Same process, AR dot AR equal to 1, A phi dot A phi equal to 1, A theta dot A theta is equal to 1. Next, A phi dot A phi is equal to 1. Same process if vector identity AR dot A theta become 0 in similarly remaining portions. Coming to the ranges of R, it is starting from 0. So therefore 0 less than or less than infinite. Next, theta 0 less than or equal to theta less than or equal to pi. This theta is called colatitude angle. Next, phi as it is 0 less than or equal to phi less than or equal to 2 pi. So this is the same previous circular coordinate system. So in similar fashion, vector A represented in spherical, where A is equal to AR plus A theta plus A phi. Look at AR, A theta, A phi are called components of A along R comma theta comma phi direction, where unit vector AR, A theta, A phi are called unit vectors along R comma theta comma phi directions. So finally, A, magnitude of A become under root AR square plus A theta square plus A phi square. So this is about the introduction part of the coordinate systems. So by using this, we go for the applications of these coordinate systems. So I briefly describe these three for the comparison. Let us take the same. Briefly I may explain about the same thing. Cartesian coordinate system. Number 2, circular coordinate system. Next, spherical coordinate system. So the common points we have to write. See, by the comparison only we can better understanding of all the coordinate system in detail. So circular, the variables are x comma y comma z. Here the circular variables rho comma phi comma z. Spherical r comma theta comma phi. So this is the first one. Then followed by we may represent the ranges minus infinite less than x less than plus infinite. Next, minus infinite less than y less than infinite. Next, minus infinite less than z less than infinite. So this is nothing but ranges. In similar fashion, row. First one is 0 less than, because row starting from 0 towards infinite. Row less than infinite. Next, phi, 0 less than or equal to, phi less than or equal to 2 pi. Phi is azimuthal angle. Next, z becomes same, minus infinite less than z less than infinite. Spherical, it is the same, like 0 less than or less than infinite, because as per the coordinate system, it is starting from 0 towards an infinity. Same, theta is 0 less than pi. Theta is called colatitude angle, range is pi. And one more difference you identify, in a circular we have one angle, spherical we have two angles. Their two angles are, one is azimuthal angle, which is already repeated in circular. It is the same, the range is 2 pi where theta is pi. Next, 0 less than or equal to, phi less than or equal to 2 pi. So this is the first difference, variables representation. Next, this is the ranges of variables. Next, third one we will represent it in vector form. Let us take A is equal to ax plus ay plus az, where ax, ay, az are components of A, where small ax, small ay, small az are unit vectors along x, y, z direction. I am talking about Cartesian, I focused on only x, y, z. So the magnitude of A, or otherwise you may write A is equal to the vector form ax plus ay plus az. If it is a unit vector, for example, I write represented A by under root ax square plus ay square plus az square, because unit vector A equal to what? A by magnitude of A. Like that we have to represent this. In similar fashion, A. Now we are talking about circular. Circular variables are rho, phi, z. So A rho plus A phi plus az, where A rho, A phi, Az are called components of A along rho, phi, z direction, where unit vector A rho, A phi, Az are called unit vector along rho, phi, z direction. Similar way we have to represent it in circular. Same, A rho plus A phi plus Az under root magnitude of this A rho square plus A phi square plus Az square. Similar fashion this one, A. We are talking about spherical, variables are r, theta, phi. You may represent the same, AR plus A theta plus A phi. We represented unit vector. This is A by magnitude of A. What is A? AR plus A theta plus A phi divided by under root AR square plus A theta square plus A phi square. Yes. From the vector identities, you may write one more, like ax dot ax is equal to 1. Similar way, a rho dot a rho is equal to 1. Similar way, ar dot ar is equal to 1. Like that, you have to write remaining parts also. So this one is the basic comparison of type of coordinate systems: Cartesian, circular, and spherical. With the help of this and applications of this, we proceed with to understand of our electromagnetic theory subject very easy. So then we proceed with the applications. So basically there are three applications. All three applications represented in Cartesian, circular and spherical. So first I'm talking about applications of this. Applications of coordinate system. First one, differential length. Differential length. It will be represented as dl. D stands for differential, L stands for length, differential length. Number two, differential surface. D stands for differential, S means surface. Number three, differential volume, that is dV. Here we know length. Length is nothing but distance between 2 points. This is called as a length. We know surface. Surface is nothing but length into breadth from the basics. Length into breadth. This is the width, this is the length. Right? Volume. Length into width into length into and height. Right? So length is distance between 2 points. Surface, length into width. Volume, length into width into height. So what is differential length? Differential length is nothing but this is a total length. In this I'm identified a small length. This is called dx1. Let us take. Next dx2. Next dx3. This is called differential. Differential means separate. Integration means combine. So we are talking about a differential length. So let us take one length of the line. The length of the line is from 0 to infinite or minus infinite to plus infinite. We are unable to identify infinite value. Therefore, we may consider the small portion. This is called dx. That is called differential length. In similar way, this is the total surface. We have to find out the small area. This is called differential surface. This is your length. This is your width. A small area like that. It is also one small area. This is called a differential surface. In similar way, differential volume also. So in this scenario, differential length, differential surface, differential volume, these three parameters introduced in our coordinate systems. How to analyze this? All these three applications into the coordinate system that we are going to discuss now. So first one deals with differential length, differential surface, differential volume by using coordinate systems of Cartesian. Cartesian application discussed. In terms of differential length, surface and volume. See, in this, it is completely analytical part. Accordingly, we have to write the expressions, which are very much helpful for electromagnetic theory subject. So in this, we are using I consider one square box which is placed in the free space. So we can easily identify the point in a free space with the help of the coordinate systems only. There is no other option for us. So let us take then coordinate systems now. This is x, this is y, this is z, then 0. Because it is Cartesian, variables we know already, x comma y comma z. So we discuss applications. Applications are three, already clearly mentioned: differential length, differential surface, differential volume. These three parameters discussed in Cartesian. So let us consider a box, rectangular box. It is a 3D box. It is length into width into height. It is also there. This is a 3D. So generally 2D means only length into width. So let us take A, B, C, D. This is one box. This is called front view. P, Q, R, yes, this is the back side of the view. So this is a box. I apply this analysis to the Cartesian. Cartesian variables are x, y, z. First time deals with the differential length. Differential length in Cartesian coordinate system. See, for example, we are at this position. We are in this position. I want to move from D to S. I want to move from D to S. So D to S means this is the point. So this is nothing but a distance between the 2 points. It's not a total length, it's small length. The small length we consider what? DL. So therefore, differential length, this is along which direction? The direction represented by the Cartesian. Cartesian variables are what? X comma, Y comma, Z. So therefore, you can verify it in which direction it is. This is the X direction. So therefore, this is the length. That length is called differential length. Therefore, it is called DL. But it is in which direction? X direction. Therefore, this is the direction is called dx, X direction. Therefore, DL is equal to dx into, we mentioned the direction. Direction means unit vector coming to the picture, AX. So we want to move from D to S means distance from the 2 points, a small length is coming to the picture, that is called differential length. Along which direction? X direction, dx into AX. For example, I want to move from D to R. Let us take. So first I want to move from, there are so many possibilities, but I want to proceed this. D to S1, next followed by D to R. I want to move from D to R, this is one of the way, D to S and S to R. So like this, first D to S, next S to R. Now this is a small length, differential length, along which direction? X direction, therefore it is called dx. This is towards Y direction, therefore it is called dy. So we may write dy here. So differential length along or towards D to S or D to R is first D to S, S to R, where DL become first one dx, AX, D to S, next S to R, this is Y, AY into dy. Okay, D to S and S to R. Next I want to move from, for example, D to Q. Once again check the possibilities. D to S, S to R, R to Q. So we can cover all the directions, X comma, Y comma, Z direction. Or otherwise you may go like this also, no problem. D to C, C to R, R to Q. This is what? dy. This is what? dx. This is what? dz. So we can cover all. So let us take, we want to move from D to Q. Move from D to Q. Check the possibilities. I choose one path. First one is D to S, followed by S to R, from R to Q. First D to S, D to S, this is D, this is S. This is an X direction, variable X direction, therefore you write dx. This is R direction, S to R, this is Y, because S to R is parallel to this Y. Next R to Q, R to Q, this is R to Q, right? R to Q, this is Z, dz. So therefore dx, dy, dz. Therefore differential length become first one is dx, unit vector AX, plus dy, AY, plus dz, AZ. This is called differential length. That's the first application of your Cartesian coordinate system. Differential length in X comma, Y comma, Z direction. Because we are talking about Cartesian, variables are X, Y, Z. So sometimes the people are confused. They write the Cartesian, they are introduced rho and phi. So if you're talking about the particular coordinate system, you focused on only that particular variables only. So this is about differential length. What the second one? Second one is differential surface. Differential surface, I already mentioned, differential surface means length into width. So look at this box. What is the area of the box come under X direction, Y direction, Z direction? So look at all of you. For example, I place the same box at an origin point, like this, I placed origin point. Consider which box is come under X direction. This is actually positive X. Okay, we are placing this box here. So this, look at all of you, this is the line is passing through it, X direction. This is a box. What is this box? This total box. This is a box. Why we consider box? Because we are talking about a surface. Surface means what? Length into width. So This is the box you may consider. So I'm talking about differential surface is one more variable, one more application we discussed in Cartesian. So differential surface along x direction I'm going to discuss. ds along positive x direction. Positive x direction. So you look at A, B, C, D. Surface is nothing but an area. Length into breadth, that point I have written as A, B, C, D. Like this. Let us take A, B, C, D. This big box come under positive x direction. Therefore, it is called AX because positive x. Then remaining parts. This is the small length along which direction? This is towards Z direction. Therefore, you may write DZ. This is AB. It is also small length in which direction? Y direction. Therefore, we have to write dy. Therefore, differential surface along x direction is, this is the direction AX, remaining parts dy, dz. This is the way we have to analyze. For example, same box were considered for opposite of this box. That means A, B, C, D come under positive x direction. Let us take P, Q, R, S come under negative x direction. If you write the negative x direction, it is the same, but we have to represent the box. This is the box. This is what? Negative x direction. So, X, this is negative, P, Q, R, S. Or otherwise, we can place this box at an origin, we can expand like this. So, P, Q, R is coming to the positive x direction, where P, Q, R is coming to the negative x direction. So, accordingly, we have to write this. So, once again, this is called minus AX. This is dz, this is dy. So therefore, differential surface minus ax dy dz. Next, this is for x direction only, but there are three variables. X is over. One more, we proceed with the dy. This is already previously right. Dx ax plus dy iy plus dz az. So x direction is over. ds along positive y direction. Positive y direction. Same, it is a surface. So therefore, consider this box. What is the area come under positive x y direction? We know already this is positive y. This is positive y. Coming to the box, what is the box of the area coming to the positive y direction? So this is y direction means this is the y, we are traveling this. So this is the area covered. So what is this area? We drawn. Look at. So this is the y direction. This is the area we can cover. This area become B, Q, R, C. So this is towards y direction. Therefore, direction we represented unit vector ay. This is towards a small length along direction is called dy, sorry dz, because it is in a direction. This is x. So therefore we have right dx. So therefore differential surface along positive y direction become first right unit vector ay, remaining parts dx and dz. This is about positive y. Coming to the negative y. Why we are talking about positive x, negative x means x is the range from minus infinite to plus infinite. Therefore, that is the direction which is traveling towards positive as well as a negative. Next, for example, negative y. This is the negative y. You can draw here. This is towards negative y direction. So this is the area of the box we can cover. What is the area of the box? A, P, S and D. You may write like this. Same. We represented the same. Sorry. We represent the same, that is A, P, S and D. This is towards negative y, that is AY. This is dx, this is dz. So same, differential surface along direction negative y, that is minus ay into dx and dz. So x direction is over, y direction is over, we proceed with z direction. So coming to the box once again, what is the area? Come under positive z direction. This is what? Z direction. So for example, I want to move from in this direction. Look at, so this is the box covered by the area because length into width. So this is the box area considered towards z direction. Therefore, differential surface along positive z direction, the box we may write. So this is A, this is P, Q and B. This is towards z direction, AZ. This is the small length along x direction, so therefore we may write dx. This is towards y direction, therefore we may write dy. So differential surface along y direction become AZ unit vector along the direction is z, remaining parts dx and dy. So look at this, the first differential surface x direction, differential surface in y direction, differential surface in z direction, and similarly consider a negative z direction. What's a negative? So for example, we can draw like this. This is towards negative z direction because it is an origin. This is towards positive z, this is towards negative z. So if we draw come like this, this is the box of the area coming to the negative z. So we may write minus AZ. So finally the conclusion is, we are finding differential surface along x direction, y direction, z direction. The point we are observing, if it is in along x direction, we have unit vector ax, remaining two differential components, dy, dz. There is no dx component because differential surface is only the x. Similar way, differential surface along y, we have unit vector ay, there is no dy, dx, dz is coming to the picture. In similar fashion, differential surface along z direction, we may get az, dx and dy. There is no dz component. So finally we conclude, differential surface along that particular direction, there is no differential component. Remaining two differential components are coming to the picture, but the unit vector in the same direction. So this is about applications of Cartesian coordinate system in terms of line and surface and volume. The volume is nothing but x into y into z. We may write dv is equal to dx, dy and dz. So there are three applications. First one is a line, second one is a surface, third one is volume. This is the applications of Cartesian coordinate system. Similarly, we are finding circular coordinate system applications also, like length, surface, volume. That is differential length, differential surface, differential volume. But we have to clearly understand these three-dimensional figures. Accordingly, we have to write all the length, surface and volume. It will become very much useful to understand electromagnetic theory subject. There are so many laws we are going to discuss: Gauss law, Ampere's law, applications of Gauss law, applications of Ampere's law. All the figures will be like this three-dimensional. Accordingly, we have to write all the differential length, differential surface and differential volume. Then concluded, the Cartesian coordinate system applications are differential length, differential surface, differential volume for this Cartesian. For Cartesian variables are x comma y comma z. So therefore, so differential length along x direction, we discussed dx into ax. This is for x direction. Differential length along y direction, dy into ay. This is along y direction. Differential length along z direction, dz into az. This is along z direction. So these are all differential length along x comma y comma z, because length is distance between only the 2 points. Coming to the surface, surface means already mentioned length and width. So differential surface along x direction. Along x direction, there is no differential component. Unit vector ax is there. Remaining components dy, dz. Next, differential surface along y direction, ay, dx and dz. Differential surface along z direction, az, dx and dy. This is x direction. this is y direction, this is z direction. Then volume V become x, y, z, that is dV is equal to dx, dy, dz. This is about the applications of Cartesian coordinate system, the summarized table. So thank you everyone.